Hello and welcome to a new video. This is for Matthew C. Zeta, and I'm excited. That's probably going to be annoying, but I'm excited about this because I like teaching new things, and so this is my first time teaching this concept, which a lot of the things in Zeta have been my first time trying to teach this concept, but I don't know, for some reason I'm really excited about this one. So what we're going to be doing is talking about division. I'm going to use the term long division, even though I think long division has a bad rap in general, which is frustrating because it's actually really cool. But we are going to start to introduce the idea of how decimals come into play with division, because in case you didn't notice already, in Zeta we've added decimals, we've subtracted decimals, we've multiplied decimals, so it makes sense that now we're finally at the point where we're going to divide decimals. Before we do that though, I think division is something that we can easily forget the steps of, so we're just going to do like a normal run-of-the-mill sort of division problem to get you ready for adding on to it something new. So let's see, what could we divide? I'm going to pick something super duper random like 58. We're going to do 58 divided by 7. Okay. No, let's do a bigger number. Let's do 580 divided by 7. Okay, so here's the process we go through to do division. We set it up like this first, if it's not already set up, and then we take the number outside and we say, how many times does that number go into? And we start off just looking at the very first digit. So we say, how many times can 7 go into 5? The answer to that is 0 times, because 7 is bigger than 5. We could write 0 up here if we wanted to, but typically we don't, because when we write our end answer, we aren't going to put any zeros to the left of our other numbers unless there's a decimal involved. So then we move over. I learned actually to put a line over the spot where you start actually dividing. So because we didn't do 7 into 5, we wouldn't put a line over it. But we are able to do 7 into 58, so that's why that line is right there. We say, how many times does 7 go into 58? Now, if you don't know your multiplication tables well, this is going to be a bit trickier, but you just got to make do with what you have, right? So 7 goes into 58 8 times, because 8 times 7 is 56. So then we subtract that. We say 7 times 8 is 56. We subtract 58 minus 56 is 2. My favorite part of long division is now we drop the next number down. So we draw an arrow down. You don't have to, I guess, draw that arrow down, but I think it's fun. We drop the number down because now we say, okay, how many times does 7 go into 20? That would be twice. And so we subtract the 14. 20 minus 14 is 6. And we don't have any other numbers to drop down. So probably before now, you learned to do this one of two ways, or both ways. You might have learned this as, I'm going to put an R for remainder and then write that number. That means that what we're saying is 7 goes into 580 82 times with a remainder of 6. That's one way of writing it. You may have, if you kind of last school year or whatever, learned about fractions, you may have learned that there's a way to write this as a fraction, as a mixed number. And that would be where you say it's 82 and what's left over, which is 6, over what we started with, the 7. So this is 82 and 6/7. So that might be a way you know how to do it. Today, we're going to introduce the idea that we also can write these as decimals. So I'm really excited about that. Let's see how that's going to work out for us. Specifically, we are going to be dividing a number that has a decimal in it by a whole number. And we're going to build off of this knowledge in the next lesson by making things a little more complicated. But hopefully, just this starting thing we're doing isn't a ton to add to what we already know how to do. That being said, if the long division problem we just did gave you issues, you might go ahead and sit and try to do a few more easy long division problems to just remind yourself how to do it. Because if you can't do regular long division, adding something new to it isn't going to work out super well. All right, let's look at this. 21 divided by 5. So this first step is to set it up. The 5 goes outside and the 21 goes inside. So here's how this works, right? We say, does 5 go into 2? And if so, how many times? 5 does not go into 2. Then we say, does 5 go into 21? Yes, it does. It goes in 4 times. We write that 4 up above the 1, and that's going to be more obvious after this lesson than it may have been in any other time that you've been doing this. We write it up here. It goes in 4 times. We subtract 20. Now, if you were working ahead, that might have been bad because we're going to do something different now. We are going to say, well, why stop at 21? Because couldn't we put a decimal, because there secretly is a decimal there, we just didn't write it because we didn't need to. Couldn't we write a decimal point there? And couldn't we put a 0 right there next to it and then drop down that 0 so that we can keep dividing? The answer is yes, we can do that. And that's how we are able to get decimal answers that we've never gotten before. It's so exciting. Now, it feels a lot like, at least when I think about it, and probably when you think about it too, it feels like the problem with fractions and decimals is that each thing has different rules. So addition and subtraction were similar, that you line up the decimal, but multiplication was different because you had to count the decimals, and that's how many decimals your answer had. Division goes back kind of to the first thing. We are going to say, since the decimal is in between that 1 and the 0 that I added, we're going to put the decimal up above it next to that 4. That is why we put the 4 above the 1, is to help us keep track of where the decimal point is supposed to go. Okay, so then we say, how many times does 5 go into 10? It goes in 2 times, minus 10, and we get 0. So there's nothing left for us to keep going. When we get 0 here at the end, or however long it takes to get a 0, that's when we would know that we are done, is because there's nothing else we can do if now we have 0. Because if I keep adding zeros and dropping down zeros, I'm just going to keep getting 0 over and over and over again. So the answer to 21 divided by 5 is 4.2. Now I can check that answer pretty easily, or at least straightforwardly, by doing 4.2 times 5 and seeing if that gives me 21. So let's see, 5 times 2 is 10. 5 times 4 is 20, carry your 1 and get 21. We've got 1 decimal here, and so I put it in between the 1 and the 0. So I get 21.0. That is the same thing as 21, because if we have 21.0, we don't need to write the 0.0. We can just write it as 21. Okay, so I've got lots of examples here that we're going to walk through, and so if it's not quite making sense, that's okay. Keep with it. Try to think as I'm going through the problem, like, why am I doing what I'm doing? Try to kind of guess what you think I am going to do once you start to feel like you've got the hang of it, and then see if you're right. And if all else fails, grab a parent or sibling or friend or someone to sit and watch an example with you and talk through it with you, because even if they don't know a lot about math or don't particularly like math, just having somebody to actually talk to while you're doing a math problem can help a ton, even if they don't say anything. I can't tell you how many times I've walked up to a student's desk and they've like talked to me about a problem and then been like, oh, I totally get it now, and I literally said nothing. I like to think that's because I'm magical, but I don't think that's what it is. Talking out loud can be super helpful, so I want to encourage you to try that. Let's look at B, 62.4 divided by 2. So I'm going to write down our 2 on the outside and our 62.4 on the inside. We could, since this already has a decimal, go ahead and put the decimal up above just so we don't forget it later. That is an option. Or we can wait until it comes up later on in the problem, whichever. So I'm going to do, how many times does 2 go into 6 if it goes into 6? It does. 2 goes into 6 3 times. So I'm going to write a 3 up there. I'm going to say 2 times 3 is 6. So I'm going to minus 6, and I get 0. And then I drop down the next number. So the thing I like about long division is it's very repetitive, because now it's like we're starting over with our first question. How many times does 2 go into 2? It goes in once, so I write that up above. I say, what is 2 times 1? It's 2, so I subtract that. And then I drop down the next number. If we were doing a really, really long number, it would just keep going, the cycle that we're doing. We're just doing the same thing over and over again, which I think is fun, but you might not think is fun. 2 goes into 4 2 times. So then minus 4. Since we got 0, we do not need to keep going. Our answer to this is 31.2. So there you go. Let's do another one. All right, 63.54 divided by 9. Okay, so we're going to start this off. I'm going to put the decimal up above so I don't forget it later. I feel like that's something I would forget to do later if I don't do it right now. I'm going to take the 9 and say, does it go into 6? No. How about how many times does 9 go into 63? Hopefully 9s are better than other multiplication tables because they have such a neat trick, right? That if the digits add up to be 9, it is divisible by 9. So we automatically know 63 is divisible by 9. And then there's this connection, right, where there's actually a thing you can do with your fingers where if I have 6 fingers, well, yeah, 6 fingers. I'm going to do it backwards on accident. 6 fingers and then 3 fingers over here, which makes 63. Which number is this? This is my 7th finger from my left. So to get 63 is 7 times 9. I don't know if you've heard of that trick before, but it's a pretty cool one. So 9 times 7 is 63. So we subtract 63 and get 0. Does 9 go into 5? No. We have to put the 0 up. So at the beginning, when 9 didn't go into 6, we could have put 0, but we didn't have to. That's just because of the way we write numbers. But here, at least for right now, I do need to put that 0 there as a placeholder. If it ended up that I didn't have anything else to the right, I wouldn't need that 0. But I am going to end up needing it. So I put 0 up at the top. I subtract 0 and then drop down the next number and say, how many times does 9 go into 54? It goes in 6 times. So see, having that 0 there makes a difference because 7.06 is not the same as saying 7.6. They're kind of close, but kind of close isn't really what we're going for in math. We want to be exact when we can. So 9 times 6 is 54. So we subtract and get 0. That means we're done. Our answer is 7.06. Okay, let's look at D. And this one has some trickiness to it. You're welcome to work ahead in general, like anytime you do a set of problems with me. But this one, I do want to warn you, I picked on purpose to be tricky and to talk about something, and I'm really excited about it. So we're going to divide 1 into 3. No, that's the wrong way. That's a very, very different situation. We're going to divide 3 into 1. That's the other thing about this, though, that you may notice is that we are able to divide things that are bigger. Like 3 is a bigger number than 1. So if you are taking 1, so 1 pizza, and you're dividing it into 3, you're going to get fractions or decimals, right? That should hopefully make sense. So here we go. 3 goes into 1 no times. So we're going to have to add a decimal and a 0 and then keep going. So 3 goes into, and ignore the decimal to say 3 goes into 10, because that's how this works, is we just kind of keep thinking, if I add a 0, what is it? So 3 goes into 10 3 times. So I'm going to subtract the 9, and that gives me 1. I can add another 0 and bring it down, and I get 10, and then I start over. 3 goes into 10 3 times. 3 times 3 is 9. We get 1. We can drop down another 0. Whoa, whoa, whoa. Wait a second. If we keep adding zeros, we're going to keep getting the exact same thing. I knew that at the outset of this, by the way. So what's happening here is that no matter how far we go, we're going to keep getting 3s. We call this situation a repeating decimal. So we would call the answer to this 0.3 repeating. And there's a way we write that actually to signify that it's repeating, is we just, whatever is repeating, which in this case is a 3, we put a line over it. And anyone who's looking at that's been at least this far in math knows that you mean that the 3 goes on forever. So 1 divided by 3 is 0.3 repeating. If you remember a few weeks ago in our workbook and lessons and things like that, we talked about decimals and fractions that were equivalent, and there were some that it was suggested to us to memorize, like 1/2 is 0.5, 1/4 is 0.25. 1/3 was not one of the ones mentioned, partially because of this thing that happens that makes it interesting, but also kind of a frustrating fraction or decimal, is that it's not just 0.3, it's 0.333333333 forever and ever and ever. It never ends as far as we know. I also want to point out the connection to last lesson where we talked about pi, because I realized in thinking about this lesson that something I said last week may not have really made sense. Pi goes on forever, just like I'm saying 0.3 goes on forever, but pi doesn't repeat, and you may not have actually realized what that meant. 0.3 repeats. Any fraction you divide has some sort of pattern that repeats. So that's one of the interesting things about pi, is that we can use fractions that are close to being what pi is, but we don't know of an actual fraction that would equal pi, because fractions in general, when you divide them, end up repeating. I put this out here. I don't think that the Math You See workbook is going to make you do this, at least in this lesson. So it was really just for the fun of being able to show you that. So hopefully you enjoyed that as well. Now we're going to do 2 more. And so hopefully at this point you're starting to get the hang of it. We're going to do 123.45. I am very creative whenever I come up with example problems. I don't know if you've noticed. We're going to divide 3 into 123.45. So, does 3 go into 1? No. Does 3 go into 12? Yes, it goes in 4 times. And then we drop down our next number. 3 goes into 3 once. Hey, make sure to put your decimal up above the decimal place. 3 times 1 is 3, so I'm going to subtract 3. 3 goes into 4 one time. So 4 minus 3 is 1. And I drop down the next number. 3 goes into 15 5 times. So this answer is 41.15. Ta-da! Last one, example F. So I'm going to divide 5 into 0.0825. So this whole thing where you might see 0 point whatever, that the 0 on the left is just to, I don't know, to make it look nicer. Like as a kid, I did not really enjoy putting the 0 in front of the decimal, but now that I'm a teacher, I prefer to have the 0 there. So you don't have to write that 0 there. And as we're dividing, we could put the 0 up here, say 5 doesn't go into 0. We put our decimal, 5 still doesn't go into 0. And that's helpful in that it does help us know where our placeholders are. 5 goes into 8 one time. So I don't know why I put the minus sign way over there. And I also almost made an 8 there, but then changed it to a 5, so we're fine. 8 minus 5 is 3. And then we're going to drop down our 2 and say, how many times does 5 go into 32? Well, that would be 6 times, because 5 times 6 is 30. And then drop down our next number. How many times does 5 go into 25? It goes in 5 times. So that gives us 0.0165. So I think occasionally in this section, you may have some problems where you have to add a 0 at the end to keep going a little bit. We're not going to be using the idea of I can just put a remainder from here on out, basically. And then there are word problems on this that you should assume that you're going to divide to find the answers, because this section's about division, right? So I think all of them probably, at least in A through D, probably have to do with division. So see if, in the context of that, if you can figure out what it is you're supposed to divide. Thanks so much for watching. I hope you enjoyed this. I'm really excited that I got to tell you about dividing decimals, and I'll be excited next week whenever we talk about more dividing decimals. And I hope you'll join me there. Like the video if you haven't already, subscribe if you haven't already, and have a great, day, whatever it is, where you are. Bye.